All right, so what are we dealing with today? Well, last week I introduced this number e. Right? Remember how we got e? We did a little exercise, and I had a silly little story about a bank promoting, and you got 100% interest for 1 year for $1. What do you get? And you ended up at the end of the day, we ended up with this special number e. So it's 2.71828 ... It goes on forever. It doesn't repeat. It doesn't end. It's very similar to pi, right? Turns out pi is actually way uglier than e, but that's a whole different story for a different day. But e is huge when you are dealing with exponential and logarithmic functions. Absolutely huge, right? You don't know that yet because you really haven't played with it very much. If I just gave you log of 7, if anytime you just have a regular log and there's no base, it's an understood base 10. Right? Does everybody understand when you see log, it's really log base 10? Well, there is a log base e. That log base e has a special name. Right? That special name is called natural log. So anytime you see this ln, right, that means natural log. Okay, I'm going to pause because I don't want to get in trouble for some. Okay. Why on earth is it called natural log? Because why isn't it NL if it's natural log? Came from Europe, so you think of it as logarithm natural, where they put the adjectives. Sometimes some languages reverse that. If you want to sound really fancy, you can call them Napierian logs, because Napier was the guy that basically started the whole thing. So, all right, how do you deal? First, let's talk about solving natural log stuff. So, example 1. So, if I give you 3 natural log of 10, let me make that legible. 3 natural log of 10 minus natural log of 8, and I say write this as a single logarithm. The way you write this as a single logarithm is exactly the same way you would write it if it was log base 3, log base 4, log base 10. What do you do with the exponent? What do you do with the number in front? Make an exponent. So that gives us natural log of 10 cubed minus natural log of 8. And what do you do when you're subtracting? Make it dividing, and so you get natural log of 10 cubed over 8. And you can simplify all this, but you see how it works just the same? It's exactly the same as just a regular log. So if you ever see the natural log symbol, treat it just like all the other logs we've done for the past couple of weeks. Now, here's the part that's a little interesting. So I want everyone to write down like e to the 3x is equal to 4. So I need everybody to write that down. Because I haven't talked, we've talked a little bit about this, now I have to really sort of nail it down. So this is similar to the problems I made you solve like yesterday. You have to solve it, right? Everybody okay? All right. And you can't handle a variable in the exponent. Okay? So what do you do? What would you do yesterday? Like if I gave you 5 to the 3x equals 4, what would you do yesterday? You take log of both sides, right? And the reason you take log of both sides is that lets you bring the exponent down in front where you can handle it, right? Well, it turns out you can use any log you want. Now, the two major logs we're going to use are regular log, which is log base 10, or a natural log, which is log base e. Now, the reason those are the two we're going to use are those are the buttons you have on your calculator. Right? So if you get your calculator out, does everybody see the log button and the natural log button? Right? They're down on the left, pretty easy to find, right? So you can use either of those logs. Which one do you think we're going to use here? Natural log, right? Does it make sense that we're going to use natural log? Because if we've got e, we should probably use the logarithm that uses e, right? So what I'm going to do is take natural log of both sides. So I get natural log of both sides, and I get natural log of 4. And this lets me bring my 3x down in front, so we end up with 3x times natural log of e. Is everybody okay with that step? Virtually identical to what we did yesterday and the day before, and Friday. Now, here's the part that's special. What's natural log of e? Probably should have asked that question before I started this whole thing. All right. What's log base 3 of 3? Are we okay? Log base 3 of 3 is 1? Anytime these are the same, we get 1. What's natural log of e? Because when you see natural log, there's an imaginary e. You see your bases are the same. So we get natural log of e as 1. Does that make sense? So anytime we see natural log of e, we get to say, hey, that's 1. So this is really just 3x equals natural log of 4. Now, just curious, is natural log of 4 a number? Can you type it in your calculator? Pretty easy, isn't it? You just press the natural log button and 4 and press enter. And so what do I do to solve for x?
Divide by 3.
You divide by 3. And so we get x equals natural log of 4 over 3, and there's your answer. Did that make any sense? All right, your turn. So if I give you 5e to the 4x equals 2, how would you solve this? What do you do first? Can I take natural log of both sides at this point? What's my issue with taking natural log now? The 5's in the way, isn't it? So you want to put the log there so you can bring the exponent down, but if you put a natural log here, you can't pull the 4 down, right? That 5's in the way. So what do? Divide by the 5. So I get e to the 4x is equal to 2 over 5. And now what? Take natural log of both sides. I'm going to take natural log of both sides. I'm going to take natural log of both sides. Then I can bring this exponent down. So I get 4x times natural log of e is equal to natural log of 2 over 5. Oh, wait, what's natural log of e? 1. Right? You're going to get really used to seeing natural log of e, by the way. Really used to it. And I want to make sure that it's instant. When you see that natural log of e, you go, oh, that's just 1. And so now I end up with 4x is equal to natural log of 2 fifths. And I divide by 4. Okay, everybody type it in your calculator. I want to make sure everybody's getting the right answer. Where's my... I want to make sure everybody can practice typing this in. I want to make sure we all get the right answer. I'll do natural log of 2 divided by 5, all that divided by 4. Okay, everybody got a decimal? Okay, I want to make sure everybody's got a decimal. And your answer to this should be negative 0.22907 and a pile of decimals I don't care about. Did everybody get that? Just making sure everybody can type this in, get the right answer, right? All right, everybody okay? All right, now, so now try this one. And if I gave you 5e to the negative 2x minus 4 is equal to 6. Solve this. go ahead and make this blanket statement. The expectation is every problem that you solve, you're either going to use log, which is log base 10, or natural log. Whenever you're doing work, those are the only logs you use. Why are those the only logs you use? Look at your calculator. How many buttons you got for logs? 2, right? Everybody understand that? Okay. Now, go through, solve it, type it in your calculator, get a decimal, because I want to make sure we know how to use the decimal thing. I mean, everybody gets the right, and everybody knows how to get a final answer. All right. So, let's see. Add 4 to both sides. Wait. Sorry. What do we do first? Yeah, right. We got to get the e to by itself. So I'm going to add 4 to both sides. That gives me 5. E to the negative 2x is equal to 10. Then divide everything by 5. So I get e to the negative 2x is equal to 2. Now we got the e by itself, so now I'm going to take natural log of both sides, so I can bring this guy down. So we get negative 2x times natural log of e equals natural log of 2. But we know what natural log of e is. It's basically just a big fat 1, so it doesn't matter, so I divide by negative 2. And so now I'm just left with computing. Let's do natural log of 2 divided by negative 2. And did everybody get negative 0.34657? So, how do we feel about these? Kind of the same thing we've been doing, right? Except because you got e, right? Everybody understand why we're using natural log? Because we have e, we're going to use natural log. Right?
What is the fraction that you wrote down?
What?
I can't see the fraction.
Oh, natural log of 2 divided by negative 2. Right? So why do you use natural log? Because you have an e in the problem. Well, what if I changed it? What if I gave you 3 times 10 to the 4x plus 1 is equal to 7? How would you solve this? Well, first, what do you do?
Is it equal to log of this now?
Not yet.
Divide by 3.
Remember, you gotta get rid of 3's in the way, isn't it? Everybody see the 3's in the way? So since the 3's in the way, let's see, I gotta get rid of the 3, so I get that. So then I get 4x plus 1 is equal to 7 over 3. Now you got a choice. You could use natural log or regular log. Which one would you rather use here?
Regular.
Regular. Why?
Because with the 10,
Because it's got a 10, right? If it's got an e, you're going to use natural log. If it's got a 10, right? If it's got a 10, we're going to use a regular log. Sometimes they call that the common log, but that's all right. And we put that log so we can bring our exponent down in front. So that's going to give us 4x plus 1 times log of 10 is equal to log of 7 over 3. What's log of 10? Is
1.
everybody okay? Log of 10 is 1? Because there's an understood base 10. Okay, log base 10 of 10, that's basically a big fancy 1. And so now how do I solve? So I'm staring at this and I've got 4x plus 1 is equal to log of 7 over 3. Your job is to solve for x. What do? We okay? Subtract 1 and then divide by 4? Everybody okay with that? So let's see. If I subtract 1 from both sides and then divide by 4, And just for fun, everybody type that in and make sure you get the decimal, the same decimal that I get. And so it's going to give me log of 7 over 3 minus 1 over 4. So you should have gotten negative 0.158005. Got that. Is everybody okay with this? All right. Well, what if it was 3 times 5, 4x plus 1 equals 7? How do you do this one? Well, what do you do first? Divide by 3, right? Still got it. This is like what we did yesterday, so that gives us 5. 4x plus 1 is equal to 7. 3. Now what? Which log do you want to use? You got a choice. You can use regular log, which is log base 10, or natural log, which is log base e. Which one do you want to use? Here's a secret. It doesn't matter. Right? Whenever you see 10 to some power, that means you're going to use log base 10. Whenever you see e to some power, that means you're going to use natural log, right? If you don't see 10 or you don't see e, you can pick any one you want. You're going to get the exact same answer. Does that make sense? And this is just like the problem. This is similar to a problem I would have given you yesterday. Right? It's not the exact. I probably should have looked up the exact problem I gave you yesterday. But do you see how this is the same type of problem that I've given you the past couple of days? So since natural log is kind of the new person I'm using, I'm going to take natural log of both sides. And so this gives me 4x plus 1 times natural log of 5 is equal to natural log of 7 over 3. The biggest difference between this problem is, we got to do a little more work. Honestly, I'm going to divide both sides by natural log of 5. So I end up with 4x plus 1 is equal to that mess, which is natural log of 7 over 3 divided by natural log of 5. And I get to subtract 1 and divide the whole thing by 4. Ugly. Everybody see how it works? This is exactly what we did yesterday, except, right? Actually, it is the same thing we did yesterday. The difference between yesterday and today is most of the problems I give you today are going to have e and 10. And so if you get e or 10, then you get to use natural log or log. Are we okay with this? Okay. And fair warning, there are problems in ALEKS, which will be on your test, where I will give you something that looks like this, and they will say, give your answer in terms of log or natural log. And so they literally want this as your answer. And make sure you use the fraction tool as many times as you want to. Make sure you keep track of what's on top and what's on bottom. All right. Next, if I give you log base 3 of x plus 2 is equal to 4, how do you solve this? Swoop. Everybody okay? Anytime you see log, the way you get rid of the log, you do swoop. And so when I do swoop, that gives me x plus 2 is equal to 3 to the 4. X plus 2 is equal to 81. Yay, x is equal to 79. Everybody okay with this? We've been doing this a while, right? All right, well, what happens if it's log of x plus 2 is equal to 3? How do you do that? You do the same way, isn't it? What's your base?
10.
10. So I take the 10, I go swoop. So I get x plus 2 is equal to 10 to the third, x plus 2 is equal to 1,000, x equals 998. Yay. Right? Everybody okay with this? I don't know if you can see where I'm going with it. Well, what if I gave you natural log of x plus 2 is equal to 3? How do you solve that? The exact same way. What's your base? E. And since your base is e, when I do swoop, I end up with x plus 2 is equal to e cubed, right? Subtract 2 from both sides, x is equal to e cubed minus 2. Everybody see how that works? Are we okay? So, what's the summary of the day? Well, we have this new thing called natural log, but it's really like the old stuff, right? It's exactly like the old stuff. It just gets a special name. And anytime you see the ln, that's log base e. Right? Everybody got it? So here is, you actually have 2 assignments.